Namaste, I am Navneet Shre of NIT Patna and I am extremely honored to present our research talk Snap Complain Validation Aware Multimodal Expert Framework for Fine-Grained Customer Grievances. This work is a collaborative effort with my esteemed co-authors Rishu Kumar Singh, Samishta Das, Apurva Singh and Triparna Saha. In today's multimodal era, traditional complaint analysis is reaching its limits. Most existing systems rely on short forms, text only content like tweets or product reviews. However, the modern reality is far more complex. Customers now supplement textual complaint with visual evidences, screenshots, or product photos across multi turn dialogues. Without disentangling these layered multimodal signals, automated systems fail to produce actionable insights for resolution teams. Through this research of ours, we here provide following key contributions. Our primary contribution are fourfold. First, we introduce Civil, the first benchmark multimodal dialogue dataset specifically for complaint analysis of such kind. Second, we propose Valor, a novel validation aware expert framework using chain of thought reasoning. Third, we demonstrate a significant gain of performance over state of art baselines. And the fourth is we provide comprehensive evaluation showing its real world effectiveness. This work of ours is deeply rooted in social impact. Our framework Valor directly supports United Nations SDG 9 by advancing AI-driven tools for robust and scalable service infrastructure. Furthermore, by enabling structured complaint analysis of complex narratives, it contributes to SDG 12 by promoting responsive product design and improved corporate accountability. This is introduction of Civil, customer interaction with visual and linguistic signal, which contains 2004 total conversation with 7101 total utterances. Here, 4478 aligned images scraped from Reddit and X are enriched in this dataset. This is being matched using clip-based matching to ensure topical relevance. This creates a robust benchmark for multimodal complaint understanding in true dialogue context. To ensure high data quality, we have achieved substantial inter-annotator agreement faces kappa score of 0.68 for aspects and 0.75 for severity. This is a sample of our dataset where you can see is multimodal and multi-turn dialogue for which is finally producing the aspect and severity as shown in this image. This is the architecture of our proposed Valor. Here, we can see that the multimodal encoding begins with text being processed via BERT and the images being processed via VIT. These are integrated via 8-head cross-attention mechanism, while we compute a learnable semantic alignment score to measure modality coherence. This is a very detailed architecture of our proposed Valor, which we can analyze by splitting into two phases, phase 1 and phase 2. This is the simplified version of the proposed architecture. That is the multimodal encoding followed by chain of thought export routing, validation export analysis, and then the fusion and integration. Let's go to the phase 1, that is chain of thought reasoning, the heart of Valor. Here, the structured reasoning is the brain of our system. Each export follows systematic 4-step process identifying the key features in text and image inputs, then determining the complaint aspects, assessing the severity levels, and then making classification decision with explicit reasoning. Then let's dive into the phase 2, that is validation through multi-perspective analysis, the validation MOE. Here, the validation phase uses 3 core matrices. Alignment measures the consistency across export, dominance ensures the validation export agrees with primary MOE logic, and complementarity ensures we capture a diverse range of expert perspective to handle uncertainty. The benchmark results are compelling. Valor achieves 81.94% aspect accuracy and 72.51 severity accuracy. This marks an absolute improvement of nearly 13% and 6.5 respectively over the strongest baseline Gemma 3. Our framework's structured reasoning is clearly an essential for handling these complex multimodal scenarios. We have conducted a detailed abelian study as visible in this table and the graph of ours, which can be concised into this that the validation MOE module provided 8.2% boost in accuracy. Additionally, our learnable semantic alignment score and the use of COT export significantly outperformed the standard transformer and static baseline variants. Real world impact and human evaluation part. Human evaluation further validates our work. Valor achieved 42.3 win rate in aspect identification. This is highest among all models. It excels in multi-aspect recognition and provides reliable expert fallback through validation layer, ensuring transparent decision making. In conclusion, Valor transforms unstructured complaints into actionable insights. Our next step would be including and extending it to multilingual scenarios and incorporating speaker role to enhance its applicability across diverse global services contexts. You can find our code by scanning through this QR. Once you go at our GitHub page, you'll find a detailed README file which will show you how reproducible our results are. You can reproduce our test and our every result as mentioned in the README. Then the dataset is available at the given link. Thank you for your time and for joining me for this presentation. We look forward to seeing you at AAAI. Thanks a lot.